Okay guys, so I couldn't find a video I liked to send you tonight to watch, so I'm going to actually make another one right now. And this is going to be compound inequality review. And basically, there are 4 different scenarios. We're talking about and or, but in each of those categories, there's 4 basic different scenarios that you're likely to see. So the first one would be something like this, where it says x is less than 1 and x is greater than 4. And so what I do is I take my number line, and I have a 1 here, and I have a 4 here. And above the number line, I'm going to graph this one. X is less than 1. So here's 1, and it does not equal, so it's less than, it's an open circle, and it goes to the left. See. All right? Then I got to graph this. X is greater than 4. Greater than 4 goes that way. Now what I'm going to do is I'm going to bring it down to this line, and I'm going to see what that does. It says, bring this down here. It's an open circle here, and it goes this way. It's an open circle. I'm just going to make it open right there. So I have to describe this final line here, and it says, but except that it says and. I'm looking for places where there's an overlap. In this case, there was no overlap. This line did not overlap this line at all. Therefore, there's no solution. So I'm just going to say no solution. I guess in these cases where they're both going in opposite directions and there's no overlap whatsoever, in a way you don't need to bring it down to this line. You could just leave it up there because it's kind of obvious, right? There's no place where they're overlapping. So really I guess I don't need to do that for this one. But you got the idea, right? There's just no place where there's going to be, both of them are going to be true. They've got to both be true. All right, now this is the same problem, only I put or in here. And we're going to try this one now. So we've got 4 and we've got 1. We have an open circle here, x is less than that. Open circle here, x is greater than 4, right? Now it says it's not and anymore, so it doesn't have to both be true. Only one of them has to be true, but actually all of them are true no matter where they are. So I have to say as my final answer, if I brought this down onto this line, onto the graph here, and drew my arrows, brought it down here, sometimes it makes it easier to see it. Well, here's 1 and here's 4, nothing here, but all of this is a solution going forever that way and forever this way, starting at these points. So I'm going to have as my answer the set of all x's such that x, and then I basically rewrite this, is less than 1, or x is greater than 4. And then I put my brace there, and I'm done. Okay, the difference between the two is pretty significant. Here there's absolutely no solution whatsoever for the and here there are. It's just that it's all starts here and goes that way, or it starts here and goes that way. All the answers in that direction, in those two directions. Okay, now let's use red for this one. Okay, so I'm going to draw my line again, and I've got a 4 here, and I have a 10 here. It says x is less than 4. So I'm going to draw a circle up here. It's an open circle because it's not equal to it. It just goes left. And then I'm going to draw an open circle up at the 10. It also goes left. X is less than 10. Okay? And now, because it says and, I'm looking for an overlap. So I'm going to bring down to this line here, I'm going to bring down only what overlaps, what's true. So this is what's true. It's not true here because there's only 1. This is not included in this. This is included in this starting here, right? You have an overlap here. So I'm going to just bring this down on the 4, make it an open circle, and I notice that as it goes left, that's where I have 2 lines. So this is all I have to describe. I don't have to describe this line here, just have to describe this, right? Because this is the only place starting here but not including 4. So my answer is the set of all x's such that x is less than 4. Okay? So I'm only bringing down to this number line what's true, all right, in this scenario with the and. Now with the or, I'm going to draw my number line again, and I have 4, and I have 10, and it says x is less than 4, less than 4. 10, x is less than 10. Okay? Now, I'm going to bring down to this number line what is possible. Or means everything that's written here is possible. So I can bring the top line down right here, right? And I can draw this line here, nice big thick line, right? And there's my arrow. And then I can bring this one down. It's an open circle, but look, it's already solid because of this line down here. So really, I don't even need an open circle. I have a closed circle, whatever. Because, and this keeps going to the left, so now I have to describe this. And the only solution is that it has to be less than 10. That's a 10. Looks like a line. Anyways, so I'd say the set of all x's such that x is less than 10. And then my brace. Make sense? In this case, x had to be less than 4. In this case, x had to be less than 10. That's the difference between and or. In this case, it's just like number 2, really. I didn't even need to do it, except that they're going in the opposite direction. So I've got, I'll use green again. So here I've got my line, let's see, my number line, and I've got a -5 here, and I've got a 8 here, and it says x is greater than -5. Okay, greater than, this way, and then x is greater than 8. Greater than 8. Okay, for and I have to have an overlap. And so here's my overlap. As I come here, it starts, no it doesn't start here because there's only this line, this line, this line, this line now. Right here is where it starts. So I'm going to bring down only what's true to the number line. It's an open circle, right? And it goes to the right forever and ever. So I have to describe that, because this is where the overlap is. I brought the overlaps down onto the number line. I have to describe the number line, which is x is greater than 8. So the set of all x's such that x is greater than 8. I think that makes sense, don't you think? And then as we look at the same problem with an or, I'm going to draw my number line again. I've got a -5 and an 8, and x is greater than -5, x is greater than 8, okay, but this time it's an or. Or means anything that's there is going to be true. So I'm going to bring everything that's graphed up above down onto the line. So I have an open circle at 5. I'm going to actually erase that part so you can see it's an open circle. And it looks like I'm going to the right. For this line, I go all the way to the right. Nice big solid line. It goes on forever and ever and ever. This line I got to bring down, but look, it's already, that open circle is already filled in by this line. All right, what am I doing? Or? Yeah. So it's already filled in. So really it's just already filled in. So I don't even need the open circle. And it goes to the right. So it still goes to the right, which is already what I had from the other one. So if I had to describe this, I would just say x, the set of all x's such that x is greater than -5. Goes forever that way, right? So the set of all x's such that x is greater than -5. All right? Last one. This is a case where they're both going opposite directions towards each other. Okay, so we have our number line again. We got -2 and we got 6. and it says x is greater than negative 2, so I have an open circle here, and I'm going to go this way forever and ever. This says x is less than 6. So open circle, I go this way forever and ever. And it says and, which means there has to be an overlap, meaning there's got to be two lines. There's only one line starting from here going this way. There's one line starting from here going this way, but going towards each other between these 2 points, there's two lines. So I'm going to bring that down to my number line. I have an open circle for this one, right? And I have an open circle for this one because it says and. They both have to be on this point, and this one isn't because it's an open circle. Therefore, I have to have an open circle on the number line. And then the two lines are everything in between, so I make this nice and solid so I can see that. Now I have to describe this point. And I could do it two ways. To describe this, I could say the set of all x's such that x is greater than negative 2 and x is less than 6, which actually is the same thing as the problem. I could do that. That's totally legal. Or I could do it slightly differently where I could say the set of all x is such that, and then I think of my x's in between, I think these are my two boundaries, outer boundaries, so I put negative 2 here, I put 6 here, I put x in the middle, and x is bigger than negative 2. So I'm reading it backwards. X is bigger than negative 2, and x is littler than 6. And then that's that. So basically the negative 2, 6, 6, x in between, and obviously the signs are always going to be pointing to the left here in this scenario, because this is bigger than this, and this is bigger than this. Or this is littler than this, and this is littler than this. Right? However you want to think about it. Last one. Or. Same scenario. Same problem, only it's an or now. Here we go. And this is the last problem, and then you guys are done with your homework. Awesome. Okay. So we got x. Let me think. Where am I? So we're on this one. So x is, okay, negative 2. There's 6. X is greater than negative 2. Greater goes on forever that way. X is less than 6. Goes forever this way. And it says or. Or means anytime there's a line, I'm bringing it down to the line. There's a line here going forever this way. It starts here with an open circle, right? And it goes this way forever and ever. I'm just doing the top one. This way forever and ever. Okay. Now this one, now I got to draft this one. This is an open circle, but I've already solidified it by this other line, by this line, because it goes through that point. So that's now a solution there. But and it goes this way, forever and ever, ever, so it fills in that open circle, going forever and ever this way. Notice now it's just the number line I'm trying to describe. It goes forever to the left, forever to the right, and there's no points that are not true. Therefore, I say the set of all x's such that x is, I could write all real numbers, or I could do a capital cursive R. I don't know if you guys know that or not, if you're learning cursive anymore. But anyways, that's how you could do it. Or you could say, you could actually spell it out. X is all real numbers. And then your brace. And that's basically it. So it's really weird not having a class here. I'm looking at the computer as though you're my class. And I'm realizing you're my class. Sorry. Anyways, this is basically the idea. So I just wanted to bring it back to a review state so that you could have a chance to look at these and see there's only 4 different scenarios. So there they are. And I think that's all I'm going to cover. I think that's all I'm going to cover for today. So anyways, thanks. I'll see you guys tomorrow.